The next thing is mode shape. So what is mode shape? Under the dynamic condition, like when we are specifying the dynamic loads of the object, due to the frequencies of the object, what happens? The body will get deformed. So what are the possible deformations we can see on the object?
Bending and stress, strain.
Sorry? You are saying something. Okay. Kale or Ashwin?
Bending,
What
deformation.
bend? Yeah,
When load is
whatever kind of deformations we can see. It's not only the bending, whatever shapes it will take. The thing I will check, like in our problem, we will check here how this object is going to deform. Okay, like what are the mode shapes we will find here under the different frequencies line. Okay, I will take the material here. That is my titanium alloy, whose material properties mentioned here. Poisson's ratio, density, everything is mentioned here. One of its end fixed to wall. And see here, in model analysis, we are not specifying any, what we can say, load. With self load only, we will check the natural frequency. Always natural frequencies we are finding by taking self loads. Okay, self load of the object. Now see here, I will go for engineering data. Engineering data source, general material, titanium alloy is the last one. Take this one, come to here. What is the density? 4620. What? How much to divide? 4480. So we have to edit the properties. So break the link source, change this value to 4480, and Young's modulus is mentioned as 1.103. 1.103 e power 11. Poisson's ratio it's mentioned as 0.31. 0.31. Okay. Now close this one. Go for geometry. Okay, it came here. Now see here, it is an I section beam is there. Okay, directly I will create one cross section. Concept, cross section, take an I section and specify the parameters here. Wait a second, change the unit system to millimeters. Width one, it's mentioned as 17.50, and the width two also 17. Sorry, it's 40. 40. 40 is the thicknesses. Then bottom below thickness is 5 mm and length is 70 mm. These thicknesses are 5, 5, 5. This is 70. 70 from the top and bottom actually. So here 70 minus 10, 60. Okay, this is my cross section. Generate. Go for extrude that one. Take this I section. Apply. How much length is there? It is 500 mm. Once again, go for I section and make this one like 80, not 60. Why? Because here it's mentioned like 80. Now our body has been created here. Like that. Okay, due to graphical properties coming like that. Now after our geometry has been created, close this one, go for model environment, and we will check the frequencies. Yeah. Now see here, check the geometry, change the material to titanium alloy. Okay. Next thing is coordinate system. Okay. Generate the mesh. Mesh should be proper here. I will increase the relevance here. Update. Okay. Now go for analysis settings. Okay. Then here what you have to do, you have to give how many modes you want to find. Means mode shape I already said to you. So how many modes shape you required here for this analysis? I want for example 10 modes. Okay. Then go for solution, insert. If you want to find the deformation, okay, click on solve. For mode shapes, you have to take the deformation, like how it is deformed. To check that one, we have to take the deformations here. So see here we are getting the total different frequencies. Initially we are getting 0, 0, 0, 0, 0 only. Then it started like 3.6007 e to the power of -3, then 298, 585, 906, 1487. These are the different frequencies we are getting here. Now we will check one by one all the frequencies. So see here what you have to do. Here I am seeing the frequencies somewhere here, and deformation I am getting like 45.11. See here the deformation whatever you are seeing here now, that is not the actual deformation, just it is showing the deformation value to you, but it is not the actual deformations. Okay, just for mode cell it is giving some values to you. Okay, then select all these values, right click, then here what you have to do, create mode shape results. See here all the results it will be come here. Initially it is showing here, if it is here means we cannot able to, we can only able to see the frequencies here, not the mode shape. But when you come to here, we can able to see the mode shapes also here. Now this is the first deformation, how it is deforming here. It is deforming somewhere like this. Then if you go for second deformation, the frequency I am getting here is 0 only in this case. The deformation is also same like that only. When you go for total deform, like third mode shape, third frequency, it is also 0 only, but it is deforming somewhere like this. Fourth one, frequency is 0 only, mode shape is like that. Fifth deformation also frequency as 0 only, mode shape is something like this, it is deforming here. Sixth one, 0, deformation is like that. Seventh one, frequency is mentioned like 3.6077 e to the power of -3, deformation will be something like this. Then eighth one, frequency is 298.45 hertz, deformation will be like this under that frequency. Then for this one, the deformation is, the frequency is 585.61 hertz and deformation will be like that. Then here the frequency is 906.05, deformation will be like that. Then for this one, frequency is 14.89.7 and the deformation is like that. So see here, based on this frequency only we can able to choose what kind of analysis we have to perform. Either we have to go for static structural or we have to go for dynamic analysis. Okay? Understand guys this one? Nothing is there, this much only we can able to check here. And one more thing, we have given the mode shapes, like how many mode shapes we required, we have given here. One more thing I am checking here, like if you don't want to give the number of mode shapes, if I want to give the limit, means the frequency limit, if I want to give, for example, I want to check the limit from 0 to 1000. Solve. I want to check the results, frequency result I want between 0 to 1000 hertz. Just give that value. For that one, I am getting, see initially we are given 10. The 10th value is something 1489. That value is beyond 1000 limit. So that is the reason that value is not showing here. Why? Because previously I have given number of modes as 10. That's why that value is showing. But right now I have given the limit range. Like I want to find the frequency between 0 to 1000 only. So that is the reason the 1489 value is missing from here. Okay? The remaining is same like that. Understand this one guys? Any doubts you can ask me now. In static structural and in model analysis.
So depending upon the deformation of the model of the figure changes, sir.
Sorry?
Depending upon the value in first deformation, the model is in a different angle, and from last deformation, the model is same.
That is possible outcomes.
Due to
Okay?
outcomes.
That is, sorry?
Due to outcomes, sir.
Yeah, might be like, we don't know. Suppose for example, if you assign the load to the body, due to the frequencies, we don't know, we can't say that it is, see, actually the thing is, it is showing something differently, like a very big deformation is showing you here actually. If it is not that much deform it will make, just for understanding purpose, it is showing here. Okay?
Yeah.
Just for understanding purpose, it is showing this kind of deformation. Actually, it will not deform like that. Little bit deformation we can see. I already said that the deformation value, whatever you are getting here, now that is not your actual deformation. Just for showing the board shape, it is showing that value.
Okay.
Okay?
Okay.
But actual thing is your natural frequency. The frequency, whatever you are getting, that is very important. So based on that frequency only, we are deciding to perform the what kind of analysis we are doing.
Okay.
Okay?
Okay.
Any more doubt?
No, sir.
Switch. Any doubt?
No, sir.
Okay then, fine. So tomorrow what we will do, we will start the, either we will go for harmonic analysis or dynamic analysis. Okay?
Okay, sir.
Okay then, fine. Bye guys.